Hey, hello guys. I decided to make a video today. I have not done a video for a long time, so I saw this message yesterday because I had the bell, and sometimes the bell will tell me if someone wrote me something on one of my videos. So this gentleman here, Matei Bogdan, 6 hours ago. It was kind of late after I read the message. Yes, last night it was too late. It was like 12 midnight, and I was about to go to sleep. So he asked me for the spring file and also for the voltage that it needs the circuit. Actually, yes, you can actually put it to work with 45 volt DC. It should be just fine. Depending on the transformer, you have a really large toroidal transformer with at least let's say 400 VA volt amps. 400 VA should be just fine. Yeah, I'm gonna send you the files, don't worry about it. So before all that, I'm going to show you the simulation, and I send you the data, the spring layout data, so you can actually you can edit the file. You don't need to edit the file. Well, what I'm gonna do is I'm gonna compress the Gerbers. This folder contains all the Gerbers in case you wanna. What is this? Oh, okay. I think I mixed up something here. It's okay. We all men, so we're gonna delete that because it's not really needed. What the hell? Why I say that in there? All right. So this is all the talking seriously. I think I was moving the files and yeah, I know. So here you can see these are all the Gerber files that they are ready to go if you want to order the PCB, and this is the 3D image generated from those Gerbers. As you can see, this is ready to go to the manufacturer so they can manufacture the PCB for you if you want to order the PCBs. I also have on the same I think I'm gonna save this 3D file, so if you want to look at it. So I'm gonna render the board, save as. I'm gonna save it into my desktop. It's okay. Save as. This is AX14T. AX14T. That's another version of the. Okay. This software that I'm using is free, so you can go to the website. Is Zof PCB. This one here, you can download COFC PCB, and you can download the files you want to look at the images of the Gerber. So you will be sure that all files they are correct, they are okay. So as you can see, this is all good to go. All good to go. You want to order the PCB. So I'm gonna close this software, and I'm gonna send you also this file. Let me see one thing. I having problem with the software because before I used to just double click into the file. You can see the file has some kind of it's like a blue icon with some traces, pink traces. So let me see. I'm gonna double click to it. Oh, there you go. I think they fixed it. Good. I think they fixed it. Now you can double click and look at the files of this PCB. You can make a halo, so you want to look through it just to check the file. I already did that, so you don't need it to verify the content of the traces. This is already good to go. All right, now I'm gonna send you also this file to your email. So don't tell me that I closed the. What the hell? Did I close it? I think I closed Mozilla by mistake. That's okay, don't worry. I think it's on draft. That should be on draft. So all right, draft. So I can continue attaching the files. All right, I will continue attaching the files. So this is the 3D image generated. I need to also compress this folder that has all the information. Okay, let me see. I'm gonna compress email It has to be. I'm going to add to AS14 3D image zip folder. It should be better. Zip folder. There you go. So this is the folder that contains all the garbage, like I mentioned. So I'm going to attach this to your email. So you will have also the garbage generated by the same. There you go. Compressed garbage. All right. Also, I have the simulation. Let me say the simulation also to the desktop. So you can have the, okay, this is version 14. This is the file for version 14 or multisync for 14. Oh, this is actually 13. So like, what I'm gonna do, I'm gonna save it as 13 on the desktop. All right, and then I'm gonna save this as, I think I'm not gonna be able to save it as 14. I don't think so. Let me see. I don't think it's possible unless I say the file is gonna turn into version 14. Let me see. I gotta see if this is version 14. No, it's still. Let me see. I gotta look at the file first. Let me see. It should be on the desktop. Okay, this is all the files. No, it's still save 13. Let me see. Let me open the file. Yeah, no. Now it says 14. It says multisync 13. I think this is the name of the file. Okay, that's the reason why. Okay, let me change the name of the file. So this is for 14. Now it's 14. Okay, there you go. Now it's 14. All right, I'm going to show you the simulation. This is the simulation that I made a long time ago, based on Miles Soloscovic circuit. Sorry, but I cannot pronounce his last name or his last name. Okay, this is from DIY.com. High fidelity audio amplifier, 100 watts. So I made a simulation a long time ago. This is still good. I'm going to show you the bias adjustment, the procedure of the bias. You're supposed to have no speaker connected. Right now I open the leads 1 and 2. So this low R27 is basically the woofer or the speaker simulation. That's the low of the speaker. I can actually change the name of the. So this is the woofer or speaker, whatever. Okay, let's go. Let's write. Let's type speaker better. Speaker. This is the speaker load. It's okay. That's the speaker, basically simulating the speaker. Right now, I'm going to change the voltage. You mentioned that you want to try with a lower voltage. 45 volts should be just fine. I don't think it's going to be any problem. I'm going to change the voltage, the rail voltage, to 45 volt DC, and then I'm going to check the bias adjustment. You can measure one of the emitter resistor. Okay, I'm going to show you the image. So basically it's from the positive rail of the amplifier. So it should be, let me see, I think it's this one here. This is the, I wait for the computer is acting up. Hold on, there you go. So this is the rail, the positive rail of the audio amplifier feeding this transistor. So basically you're gonna measure this resistor right here. This is the resistor that you will place the multimeter, and you will read a voltage there, a DC voltage of a few millivolts first. So the trim pad, this one here, this is, I call it the universal trim pad. You will adjust it to the maximum resistance first. You will use a multimeter to measure the leads. These two main leads, this one here, this larger one here, and this one here, and you will adjust it to the maximum resistance before you do the bias adjustment. Okay, so I'm going to turn on the simulation. This is the trim pad, is this one here. I should change the name. Okay, this is okay, but let's see if I can change the name or place a name. I have problem with my mouse, so my computer mouse is acting up, okay, acting weird today. So all right, so this is the multimeter to measure the bias. I change the voltage to 45 volt DC. The the voltage that you want to use. Yeah, you can use that voltage. It should be just fine. I'm going to activate the simulation right now, and I have an error. I don't know why. I have an error. I don't understand why I have an error. I supposed to not have an error. Let me see. Yep, got an error on this simulation. I don't know why. Okay. I have an error on this simulation. I don't understand why I have an error. Let me see. Don't worry about it, because I have more simulations. Maybe because that was version 13 and to change it to 14. All right, this is the same. I'm gonna change the colors of this one here because I think it might be difficult to see. Okay, let's see. Sheet, symbols, name. Okay, colors. Color. There you go. Okay, let's custom white background. Okay, let me see. This is better. This is a lot better. For some reason, I have a error on that one. Okay, this one here that you see is the, I call it the Golosa because I add more pairs, but it's basically the same circuit. It's the AX14, and we're gonna adjust the bias one more time. Sorry about the mistake on the other software, on the other file. So this one here, I gotta open the leads. The speaker should not be connected, and I'm gonna, okay, I think I already turned off all these transistors. They are off, as you can see here. And the voltage, I need to change the voltage to 45 volt DC. Make sure that, okay, there you go. And this one here, this rail should have 45 volt DC. And I need to place the multimeter to read the bias adjustment, since I already turned off all these transistors, Q15, Q16, and Q17, Q18, Q19, and Q20. They are off. I already turned them off, so I'm only using a 1 pair. As you can see, it says 1 pair, 2 pair, 3 pair, and 4 pair. So this is, I'm using only 1 pair, so this is on. This transistor is on, so I need to place the multimeter reading this voltage drop into R24. So I'm gonna do that right now. I'm gonna place the multimeter here to read the voltage across this meter resistor. That will be this one here. This is the meter resistor that you're gonna read the voltage drop with the multimeter, and then we're gonna check for the meter. Okay, then I'm going to turn on the simulation. Okay, we have 11.8. That's kind of low. We need to have 20, at least 23.5. So we're gonna change the voltage. I'm sorry, the bias adjustment. It will be this variable resistor. So that is this one here. This P11K. So it's this one here. So we're gonna start to adjust it on the simulation. So I'm gonna move this key to begin adjusting the bias. Let's continue. We need to at least have okay on the real time, on the real amplifier. This is on the simulation, but then on the real amplifier, after you build it, you need to adjust it to about 15 millivolts first, and then wait a few more minutes, at least 10 to 15 minutes, until the temperature of the amplifier stabilize. If you see any changes that it might increase a little bit or lower, you gotta adjust it. Then you will do the final adjustment to about 23.5 if you can. I mean, it might be 24 millivolts, 22.9 millivolts. It should be just fine, at least close to 23.5. Sorry, it's not 23. 23.5. Let me see. Hold on, sorry guys. 23.5 calculator. Hold on. Now that I'm thinking, hold on guys. Okay, 23.5 times 2 should be 46. Yeah, sorry about that, guys. 23.5. I just want to make sure. 23.5. So we got right now the voltage across this R24, this one here. We have 12.6. Let's continue adjusting the bias. Maybe this trim pot is too high. It's 1K. I should adjust it to change it to a 500 ohms trim pot. Let's replace it to a 500 ohms trim pot. I think should be better, so I can make a faster adjustment. So let's continue. Okay, let's see. Okay, we got we got with the trim pot as 500 ohms should be just okay. On this case, I gotta mention that the trim pad on the board, it has to be 1K. It has to be 1K. It cannot be 500 ohms. Okay? 500 ohms trim pad. It has to be 1K because we're gonna bypass the middle pad with the other pad, so it's gonna be half of the value. So make sure that this trim pad is 1K, but on the simulation it has to be 500 ohm because I'm using the adjustable resistor, so it's different. So you gotta keep that in mind. All right, so let's continue adjusting the bias. Okay, there you go. No, that's too much. It's too much. Let's continue. 37. No, that's too high. Okay. No, that's too high. Oh, okay. I forgot to change the increment of this. Okay, the increment that we have 5. So let's go with the 0.05 increment. So that will give you a fine tuning of bias adjustment. So let's continue with that one. All right. See, it's too small. Okay, let's continue adjusting. Okay, 49, that's too high. That's too high. Okay, 42 is too high. I gotta keep adjusting until, okay, we get at least 23.5 or close to 23.5. It's not gonna be perfect, guys, so don't keep that in mind. It's not gonna be perfect, but at least to get close to 23 or 23 millivolts if you can. Okay, we got 21.4 on the bias adjustment. Okay, there you go. We got 23.5. That's fine. We're gonna leave it like that. 23.5. So that's good. So we have 23.5, and we're gonna connect, enable the low of the speaker. So this, so it should be no faults. This is a fault window. I mean, this window is you can simulate a fault, a open, a short, a leakage, and you can type here the resistance of the leakage, stuff like that. So anyway, I really don't do that. I don't do that type of simulation. Maybe later in the future, I don't know. All right, we're gonna attach the connections already. There you go. This is the connection, the positive and negative of the function generator, and we're gonna check the results of this bias adjustment. All right, let's see the distortion analyzer. We have 0.006%, 100 watts. That's pretty good. 100 watts? That's crazy. Wait, let me see. Did I change the negative feedback? Picofarad. That's weird. We got plenty of power. That's kind of weird. With just 356 millivolts, we got already 100 watts to. Oh, because okay, I see. Because I forgot to change the low. Should be 8 ohms. Remember, the speaker for the home use is, most of the home use speakers are all 8 ohms low. Resistance. Sorry about that, guys. Oh my god, I'm thinking about a lot of stuff. All right, there you go. So now let's test one more time to see how this is responding. Let me see. We got distortion is 0.02%. That's pretty good. We got 50 watts. 50 watts. That's pretty nice. That's really nice. And those the output looks pretty clean, but I think, okay, let me check the distortion. It's 20 kilohertz. Let's see how it's gonna respond with the. So this should be less. Let's go with 100 millivolts from the function generator just to see how this. So the bigger sine wave is the output of the audio amplifier, and the smaller one. Yeah, I'm gonna change the color. Sorry about that. I'm gonna change the color so you will see the difference here. So I need to get me a new mouse, man. You're gonna change the color of the trace, segment color. Let's go with the yellow one, and this is the okay. This is the input of the sine wave. Let's go with the lighter color and change the color of the oscilloscopio in Spanish. Let's turn on the simulation. Okay, that's the square wave. I just want to see if there is some sort of like distortion. Okay, it looks clean. I think it looks pretty clean. That's 20 kilohertz right there. Let me change the value of the capacitor, the one that is on parallel with the negative feedback resistor, just to see if there is any change. Maybe a lower value. I just want to see. Okay, this is 47 picofarad. I think it's too high. Let's go with a smaller value. Let's say 10 picofarad. Picofaradio in Spanish. Let's see. Okay, I see the distortion. That's why I changed it. You see that peak. Okay, I see why I changed the higher value. Okay, that's like a soften the frequency, and you can see this spike. This spike is kind of doesn't look that good at all. So let's increase the value of this capacitor C7. That's up to you. I mean, you want to use this. I think it's a Mylar or Miller compensation. I forgot. Mylar compensation. Mylar compensation on audio amplifier, something like that. I forgot. All right, let's change this to 15 picofarad just to see how the output is gonna change. Let me see. All right. No, it's a little too high. The spike is kind of small right now. Let's go with the 20 picofarad. 20 picofarad. Let's see. All right, let's see. Okay, it's cleaning out the square wave. The spike right here is getting cleaner right now. You can see. Let's try with 30 picofarad. That will soften the frequency. Let me see. Oh, there you go with 30 picofarad, and looks pretty nice and clean. Yeah, I like that. Yeah, looks pretty nice. I think it's let's check the oh yeah, I'm gonna send this file right now. Okay, I made oh my god, I made a video about it. You will see it later. No, okay, sorry. About the subject. Sorry about that. About the subject. God damn it. I misspelled like a mother freak. I will send you, oh my goodness, link later. Thanks for watching my videos. All right, cool. All right, so I'm gonna send you the video to explain you better. So I send you the file right now. All right, there you go. Sending. Oh yeah, good to go. All right, let's continue with the. Oh yeah, it's a really nice cleanup. I think I read that in some area on some forum, Mylar compensation cap for audio amplifiers. Mylar. I don't know how to write Mylar compensation capacitor on audio amplifiers. Let me see. Okay, okay. Let's see. Okay, let me see. Okay, design and compensation of high performance class AB audio amplifier. Oh, that's pretty good. I haven't seen this. Let me see. I need to see images. Okay. input stages. Oh, this is pretty good. Okay. Class AB output stages. Okay, I think I'm gonna save this book. This is pretty interesting. All right, I like that. Okay. Frequency compensation, 2 and 3 stages amplify frequency compensation discuss system. Okay. Domain relationship. I think this may be a way too advanced for me, but it's good to, you know, take a look at least to have an idea. Okay, there you go. I see Mylar compensation. Okay, I see that simple Mylar compensation shown in figure 14. Okay, this is the, okay, let me scroll, zoom here. This is really interesting, guys. Maybe this is too advanced for me, but it's good to take a look at it. Okay, this is simple Mylar compensation. Okay, is well-known amplifier compensation technique which is used extensively in general operation amplifiers. It also serves as a landmark for comparing two stages amplifier compensation techniques. Okay, I see the capacitor, but I'm not sure if I'm doing it correctly. I don't know. Let me see. Maybe it should be more images, samples or something like that. I don't know. Okay, Mylar compensation. I think this is a way to advance for me. Okay, maybe, yeah, it is too advanced. Let me see. I don't know. Maybe in the future I might have a better understanding on this type of circuits. But for now, this is way too advanced for me. Way too advanced. Anyway, maybe in the future I will. So I know that there is a capacitor that you can use to soften the roughness of the square wave. Some people do that on 20 kilohertz just to soften the output of the square wave signal of the 20 kilohertz. So that's one technique, because that capacitor is also illustrated on the AX14. The AX14 is one amplifier that I already built, and it's awesome. I think it is a really awesome design. I'm going to show you the simulation of that amplifier in particular. Okay, the AX14 is also a great design too, so don't get me wrong, it is a great design. Okay, oh, this is the double bridge power supply that I was testing the other day, and it has some weird it behaves a little weird. I gotta keep looking at the. Okay, so this is the honey badger, and the compensation Mylar capacitor is this one here. I'm using a 15 picofarad. This one here, I think it's LC option. I don't know, maybe I'm wrong. I'm saying that it's a Mylar compensation capacitor, but it does work. It does work on the AX14. So you want to soften the sound of the amplifier. You don't want to hear it too rough. You can change the value of that capacitor in particular. So you want to soften that. So okay, let's see. What is the simulation? 30 no, we got 30 picofarad right there. So you can place a the negative feedback of this amplifier is this one here. The value is 47 picofarad, but this one here should be, I think should be 30 picofarad. It should be just fine. 30 picofaradio. Okay, picofaradio in Spanish. All right. God damn it. Wait, hold on, guys. Someone is knocking the door. I'll be back. God damn it, Jesus Christ. So 47 picofarad. I think you should try. Okay, it's 30 picofarad. It's okay. Don't worry about that. It's not a big deal. You can try with 30 picofarad or 47 picofarad. Should use. Okay, let's change this to 47 picofarad. Okay, it's on simulation right now. Picofaradios. All right, let's see. Okay, okay, yeah, because I changed the value of the. All right, let's see. 20 kilohertz. Looks pretty nice and clean. Nice, really nice. All right, guys, I'm gonna stop the video. I hope this is really interesting video for you guys, for the ones that like to build your own amplifiers. I already did it a couple of times. So oh yeah, I have the images of this, the PCB that I'm sending you the files, the AX14. Oh yeah, let me see. I think I have the files. Okay, let me see. Golosa. Let me see. Before I stop the video. No, what? What? What's going on here, man? Okay, this is I have only one image here. Okay, this PCB is because Mr. Terry, I sent him the files, the Gerber files, and he ordered the PCB, and he actually used it as a IPS driver for an audio amplifier, and he said it sounds really good. As you can see, this is just the output OPS of the audio amplifier, and he used the AX14 as a IPS driver board, so he used it for that purpose. All right, guys, I'm gonna stop the video. I hope you like this video. Have fun. All right.